Today we are going to see seventh chapter integrals. So for this first we must know some symbols and terms. If we write this way means this is called integral. This line is called integral. So we have to integrate for some function. That function is denoted by f of x. So with dx. This means, what is this means? May integral of f with respect to x. So this is called integral of f with respect to x. So with respect to x means we have to put dx. So this x is f of x is called integrand. This is called integrand. And dx is called variable of integration. Variable of integration. So integrate means we have to find the integral value. Integration means the process of finding the integral. So this is the common term for all the integrals. So if we integrate with respect to x means we have to put dx. If we integrate with respect to y means we have to put dy. So where integration comes from where means the derivatives. So derivatives, the antiderivatives is called integrals. So from the derivatives only we get the integral function. So first we must know the derivatives. From the derivatives we are going to derive some standard integrals. This integral is also called antiderivatives. Antiderivatives. So integral is also called antiderivative. So we are going to derive some standard formula for the integrals. So the first formula is d by dx of x power n plus 1 by n plus 1. This is nothing but x power n. So when we differentiate x power n means we put x power n plus 1 by n plus 1. From this we are getting the integral x power n dx is nothing but x power n plus 1 by n plus 1 plus c. This function is valid only for n not equal to minus 1. So n not equal to minus 1 means we have to put x power n dx equal to x power n plus 1 by n plus 1. If n equal to minus 1 means we are going to derive the next third one. We are going to derive n equal to minus 1. So what is c here? C is some arbitrary constant. Because there are infinitely many derivatives we can derive. So d depends upon the function what we are deriving. So c may be any function, any constant which is derived from the set of real numbers. So c is the arbitrary constant which is from the set of real numbers. Next formula, if d by dx of x, what is x? X means if we differentiate with respect to x means this becomes the constant 1. So in the same way integral of dx becomes x plus c. So every time we have to put this arbitrary constant for every formula. And then I already told that for n equal to minus 1 what becomes this formula. So the n equal to minus 1 means d by dx of log x. So log x becomes x power minus 1. So x power minus 1 is nothing but 1 by x. So integral of 1 by x dx equal to log mod x plus the arbitrary constant c. So next the fourth formula is d by dx of a power x by log a. This is nothing but a power x. In the derivative we are putting like that. For integral formula we have to put a power x dx is equal to a power x by log a plus c. And then fifth formula is d by dx of, so now we are going to see the formula for the trigonometry function. So sin x, for sin x integral, this becomes cos x. So integral of cos x dx equal to, thus we are putting dx here. So cos x dx, the answer becomes sin x. Sin x plus c. So the sixth formula is d by dx of minus cos x. This becomes sin x. So we have to write the formula is integral of sin x dx is equal to minus cos x plus c. So and then the seventh formula is d by dx of tan x. So tan x is nothing but secant squared x. So we have to write here is integral of secant squared x dx is equal to what? Tan x. So tan x plus c. So and then the eighth formula is d by dx of minus cot x. This becomes cosecant squared x. So this is, we can write as integral of cosecant squared x dx is equal to what? Minus cot x plus c constant. So up to 8 we have written. Now the ninth formula. So the ninth formula is d by dx of secant x. For secant x is, we know that secant x tan x. So for the integral it becomes secant x tan x dx, which is equal to secant x plus c. So the 10th formula is d by dx of minus cosecant x. So cosecant is nothing but cosecant x cot x. For integral we have to write integral of cosecant x cot x dx is equal to, so minus we have to put here, minus cosecant x plus c. And then d by dx of sine inverse of x. Sine inverse of x is nothing but 1 by root of 1 minus x square. For integral we have to write dx by root of 1 minus x square is equal to sine inverse of x plus c. So next for cos inverse of x, integral d by dx of minus cos inverse of x equal to 1 by root of 1 minus x square. So integral of dx by root of 1 minus x square equal to minus cos inverse of x plus c. And then 13th sum is d by dx of tan inverse of x equal to 1 by 1 plus x square. So which is equal to integral of dx by 1 plus x square equal to tan inverse of x plus c. So next formula is integral of d by, so no, not integral, differentiation of d by dx of e power x equal to e power x. So integral of e power x dx equal to e power x plus c. These are the standard formula for integration. Thank you.